Hello, everybody. Welcome to our ninth free webinar of the Smart Building Series 2021. Hope you're doing well out there. I'm looking forward to today's session. We've got a really interesting conversation for you all. It's titled Robotic Automation Engineers, a shortcut to energy efficient buildings. And today we're joined by Ville Ilkkala, who is the CEO of Finnish startup Valaa Technologies, and I'll ask Ville to introduce himself in a bit. We're going to be discussing the use of software robots to unlock energy efficiency in aging building stock. So the way we're going to do it today, we're going to go through this Ville's presentation, and then we'd love it if people have questions. The way to put questions to myself or Ville is in the Q&A. So if you look at the bottom right-hand side of your screen, you'll see a button, and then you'll be able to type your questions in. We'll get them here, and then we'll be able to discuss them a bit later. Beyond that, we are recording this this webinar. So it will be up on our YouTube channel either today or tomorrow. So take a look for that. I'll also put a link to it on our website. And of course, this is going to be the last webinar of this year, but we'll be back in January next year with more content for everybody. Stay tuned for that. You can subscribe on YouTube to get notified when we publish new videos. So let me introduce Ville. Hi, Ville. How are you doing?
I'm doing great, thank you.
Really pleasure to have you on today. And I guess maybe start by describing your company and yourself.
Yeah, so I'm Ville Ilkkala, the CEO of Valaa Technologies, and our startup was founded in 2018, and we started from a completely different area and topic of what we are talking about today. So been a bit of Finnish engineers and came up with a brilliant technical vision thing, but really didn't know exactly what kind of a problem it solved for whom. So we've done a lot of soul searching and so on. So basically, back in the day, we got very interested in semantic web, and probably you have been also addressing digital twins and semantic web and ontologies and stuff like that on this podcast.
Yeah, we have done that a fair bit, actually.
Yeah. But we started from this kind of an idea of a much more generic platform on which you could combine real-time kind of time series data with ontologies or semantic web in a kind of a unique way. But we created this kind of a architecture for software development in which your programming primitives were already semantic and so on. But it was a very kind of a deep tech initiative and very hard to find a customer. It was kind of, you could say, internally disruptive, that when we presented it to big corporations or something like that, it would have required like major structural changes in how they even view data. So that was a bit of a problem. But then we learned about real estate data and came into contact with the topic and thought that, hey, this is very interesting. You have buildings which are very kind of like graph-like, in which essentially like the building processes, HVAC processes and so on. You have things that feed stuff into other things, and you have measurements, and you have relationships between things. But you also constantly produce data. So we thought, hey, this is a very interesting domain to apply the technologies and the know-how that we've been working on. So that got us into real estate data, and that got us the first pilot that we started to work on. We got like a very modest challenge. Hey, here's a 250 buildings. Could you please go ahead and integrate the process data from all the building automation systems you can find into this platform of yours, and so that we can look at things from the perspective of deferred maintenance backlog and energy efficiency between building types and buildings of different eras and years and so on. And that was very interesting for the first, and very, like, let's say, went well for the first 2 buildings until we landed on the 3rd one, in which the building automation system was installed closer to the first moon landing than today. So that kind of like opened our eyes in a bit to the state of the industry, that you actually don't have the connected buildings, as you say, smart and connected buildings, or at least the connected part isn't that commonplace after all, but you obviously can't know that before you kind of try. So yeah, should I jump into the presentation?
Yeah, please do, go for it.
Sure. So basically, what we realized was that the existing building automation systems, or building automation systems in the buildings, are quite old, and upgrading them for the sake of making them compatible with cloud optimization algorithms and stuff like that is quite time consuming and expensive. And that's the goal. Let's see if I can change my slides here. So a lot of Finnish, like I'm from Finland, and I use this slide to as a kind of a wake-up call to many that in Finland are aiming to be carbon net neutral by 2030. So it's literally 96 months until then, and we are really in a need of quickly deployable, cost-effective, preferably zero initial investment solutions for getting into the point in which we could do smart optimizations and control with buildings. So probably a lot of the listeners have kind of seen these types of numbers, but 1/4 of the world's energy approximately is consumed by HVAC systems, and there's a lot of already existing companies and competition in the field of smart controls and building optimization, and energy savings promises up to 20% or even 30% nowadays are not out of question. So that kind of accounts means like it's 6% of the global greenhouse gas emissions that could be reduced by being able to deploy this kind of cloud things into optimization algorithms into all buildings, which I think is probably the biggest climate act that could be done with existing technology today. To put that into some kind of perspective, it's 3 times the emissions of the entire aviation industry. But the problem is that upgrading the automation systems to be cloud compatible is very costly and time consuming. There's obviously like regional differences in this. So Finland is a good example in which we have multiple kind of domestic brands from the late 90s that then have been acquired by the bigger players in the industry. And you obviously try to kind of safeguard the servicing side, servicing business and so on, by just simply making things harder than they are supposed to be. But I know that, for example, in the US and Sweden, BACnet compatible systems are much more commonplace. But yeah, there's over 220 million buildings built before 2000 in the European Union, which are being renovated at the speed of 1% per year. European Union is aiming to increase that to 2% by 2030 with the Renovation Wave project. And back in the day, nowadays, the lifetime or the life cycle of an automation system is a lot shorter than it used to be, but back in the days, it could be 15 years or so. And to establish a bi-directional cloud connectivity to existing building automation or legacy building automation system is a lot harder than just to read data out from one, because let's say, here's a Finnish brand, but I think the layout and the structure of this cabinet looks familiar to those who are familiar with building automation systems. You have these I/O modules that are essentially reading data from things like sensors in air ducts and so on. The data is fed into this CPU, which then basically has some internal set points or desired state of the building's processes. And then what it does is makes some adjustment calculations and then sends the data back into the I/O modules, from which it drives things like fans and valves and things like that. And how this is done is using a protocol called Modbus RTU, which means that it can have only one master, and that makes the ability to actually control this system from the cloud, ability to, let's say, for example, turn off an air conditioning machine or air handling unit, requiring you to individually program these CPUs to accommodate such a feature. So it's a very time consuming and expensive, and it's basically like something that rather or almost or probably is more cost effective currently to upgrade this into a new system altogether than to try to achieve this kind of functionality. And here's an example of a Finnish city or town and the buildings. They have 127 city-owned buildings, out of which 82, so 65% of the building stock is currently running either end of life or well beyond end of life building automation systems. So this is really the deferred maintenance backlog in the building automation systems is quite substantial. And like I said in the beginning, like we came into this field of building automation thinking that, hey, it's probably just REST APIs, or in the worst case scenario, SOAP APIs that we can have to consume, and just we can take all the data and start modeling and whatnot. And we were faced with this scenario. So back in 2019, early 2020. So it's been about 2 years now that we've been working on this. We basically purchased the internet empty of old building automation systems up until the point that we were quite confident that we have enough. And then we, in the midst of the Corona pandemic lockdowns, closed ourselves into our office and said that we don't leave this place until we come up with something new and different. And we were already a bit exposed to this technology known as RPA, or robotic process automation, which is a method of using the user interfaces intended for humans to interact with or to create automations or integrations to legacy systems. So what we realized was that when these building automation systems, this is an Atmos Tech Atmos 88, which is almost as old as I am, when they lack the cloud connectivity, or an easy way of establishing remote access to them using relatively modern and secure technologies. They usually have some kind of a local operator panel or a programming port or a method of you accessing the operating system, be it like a Linux something on the controller itself through like locally. So the technical engineer or a manager can take their Windows 3.11 laptop with a serial cable and walk into the technical space and hook up into the automation system, and then actually access pretty much everything there is to access in the building automation system, look through all the values, how it's programmed, change set points, edit values, and so on. We thought that, okay, if engineer can do it, so can a robot. So what we've been working on now is the first or initial idea and a product which has since expanded a bit, is this very simple and cost-effective IoT device, which essentially mimics humans interacting with these human-machine interfaces or programming interfaces with the automation systems to establish bidirectional cloud connectivity to legacy and old systems. And what sets this apart, obviously this is actually requires quite a bit of work from our side to make this compatible with a specific brand. But once that's done, it's actually very scalable in terms of work needed per site and per substation or per controller. So we recently did the exhibition center in Helsinki, Finland. We installed a bunch of our robots, and we were able to time the amount of, so how long did it take to integrate per controller, which there are 40. And the time total was 3.5 minutes per substation. And by the time we got back to the janitor's office, we already had like a cloud dashboard that showed the live data coming from all those systems. So compare that to something like a Modbus RTU integration, in which you do somewhat obscure Modbus register mapping, sometimes for hours and on end per system. I think that's quite an increase in efficiency once the configuration is done for a particular system. So we try to be super cost effective and so basically, like, we wanted to build a solution that the owner of a large or operator of a large building portfolio could just say that yes, please do everything, instead of making them this kind of a project after project and pilot after pilot, this kind of a very slow moving thing which didn't look the building stock as a whole, but only buildings as individuals. And since then we also worked on some, because the previous experience that we had was from the digital twins and semantic web, and we've been looking into how to actually, now that we get the data finally with these robots, how can we convert them into digital twins. And we are using the brick schema as our standard metadata schema for the processes in buildings. So we are using machine vision and some heuristic algorithms to split the building automation point labels into entities in brick schema. But then we have the IoT device robots, and now since then we also looked into building software robots that are able to read data and control automation systems via their existing supervisory systems that you have. Basically, like if you think about remote supervision service, that you have some facility manager that is jumping from one BMS system to another, checking if everything is okay. They have an Excel sheet filled with usernames and passwords and so on. So we are able to automate that as well, that we can go and use a robot instead to go and read the supervisor of an existing building automation system, and we can take things like the heat recovery efficiency rates or other important values and put them into a database, and then the facility manager can look at multiple buildings instead of just jumping from one building to another. So the kind of four things that we believe this is kind of like what are our value proposition, or what are we trying to sell, essentially, is that you can unlock all this energy optimization and predictive maintenance and enhanced supervision services without significant upfront costs that go into upgrading the automation before it's cloud compatible and so on, and also without needing these time-consuming field bus integration projects and so on. But once you kind of are able to do that, this frees up capital that you can put into things that that cannot be fixed with digital solutions. So there's like a lot of money that is needed if we aim to be carbon net neutral by 2030, that you should kind of be very frugal about it, in which things you use your money first. And I think getting data, you shouldn't spend all your money on getting data, because the data is going to tell you what to do. So now, once you've been able to do that, you can also understand better when you get data from old automation systems, when you kind of adopt this legacy first approach, that you look into integrating your old automation systems first before you move into the new sites. You can understand what you need to renovate once you're doing that. And there's also a lot of kind of error bars in quotes from contractors, and a lot of manual preliminary studies that have to be executed before you are able to renovate. But if you can affordably get like a stream of data 1 year or 2 years before it's time for renovating the building, you can understand which processes work and which doesn't, and fix exactly what you need and nothing else. And finally, when you are able to scale this into a large building portfolio, you can get this kind of a bird's eye view to the deferred maintenance backlog, and target your investments in a way that has the biggest impact both on the climate and your portfolio. So yeah, we basically, like, you could save up to 20,000 per building if looking at 2,400 square meter building with something like 300 IO points. But obviously this varies a lot, so hard to say. But as the way how we kind of position ourselves, I think it was in the invite as well, our kind of initial catchphrases that we want to be the Chromecast of building automation. If you think about the Chromecast as a product, it's essentially a very affordable thing that you can hook up to your old TV, and suddenly the whole internet is available for you. So we see this aging building stock with the legacy systems to hold like very large potential, both in terms of emission reduction, because they are consuming a lot more energy than newer buildings, as well as savings. But we don't want to compete with the actual value providers. So we want to be this kind of a sense-making middleware between companies that create added value from building data and want to actually scale their services into aging building stock, and we act here in the middle as this kind of connecting these two. So we work with engineering consultancies, facility service companies, automation contractors. We also have a strong focus in frequency containment research, so virtual power plant side of things, that how can you enable demand response in buildings without doing bigger renovations in them. So here's one of the last slides about the statistics or the city, Finnish city I had in the one of the first slides. How can we kind of transform the situation in their buildings after we do this robot invasion? So they had 91 sites with end-of-life control system. The total renovation budget needed to upgrade all of them was approximately 3.8 million euros, and annually they lost the potential savings due to lack of non-optimized HVAC was around 713,000. So with the combine of the PLC robots, so the IoT devices, and the BMS robots, we were able to integrate over 94% of the city's building automation systems to generate the potential for HVAC optimization almost 700,000. So this still work in progress, and like I said, our role is not to actually do the optimization. And like I said, we are quite new into the building automation or building technology side of things. So our role is very much this connector instead of an expert in how to optimize buildings. We know that a lot of companies can do it. So we are just there to kind of make it possible. Okay, I think that's it for the slideshow, and we could go into questions.
Great. Yeah, absolutely. Maybe you could keep some of the slides up. We can use them as some discussion points. That would be great. But yeah, as Ville said, anyone who has questions, please let's take them now. Yeah, I guess they can obviously be about the slides we've shown, or any extra questions that extend what we've talked about. You know, we're happy to open the discussion out to consider those things as well. Yeah, I mean, it was really interesting. Thanks, and that's why I sort of wanted you to come onto the webinar today, because this isn't something that or let's say an approach that I have seen before personally. And yeah, it's really interesting, and I think it would speak to like a lot of people who are operating, building portfolios, right? Who have sort of quite a lot of different types of buildings with different types of legacy systems. I mean, that must obviously like a headache for a lot of different people. I think one of the best slides you showed, or for me anyway, the best slides you showed, with the last one about opportunity, that shows the different types of legacy system. Yeah, this one. That's sort of interesting, just to, maybe you could talk a little bit, because whilst I think I get the concept and I have some questions about it, but with regard to, like the very specific kind of types that you can see them listed there, the different providers, different types of building management system in this case, like how do you actually go about like getting the data out, right? So, and you mentioned this using the human interface.
Yeah.
But that's, it sounds quite complicated. It must like a quite complicated process. But do you think maybe you could
Yeah,
discuss that a little bit?
not really made any easier by the automation system providers. So essentially, like we can use an example of, I don't know how many of the audience are familiar with particular old automation systems, but something like Honeywell Excel 5000 or TAC Xenta or something like that. They basically have some kind of a screen plus buttons contraption that is attached to the controller, and that usually is using something like serial connection. So it's a RS-232 or something like that.
Right.
The cable that goes between the automation system and the screen device, and what you have there going in the cable is essentially like screens, textual screens. If you remember your old command line tools or DOS or whatever, where you just went like press 1 to get into that menu and 2 to get into that menu, and then hit enter or down plus to move around these views. And basically what happens when you click on a button on one of these displays is that it sends some kind of a character to the controller, and the controller decides, okay, this is what is expected for me to send back. So what we do is that we cut the wire, and we put our sniffers and oscilloscopes and what have we in between and try to figure out, okay, what's going on here.
Okay.
And then we program it into a simple, like a program in which the device is actually capable of doing these things in a sequence, so that you basically, the robot has a series of tasks programmed into it. So you might have things like read all the analog or read all the analog input values, and those might be found from a menu behind 1 and then 3 and then enter. So it basically travels into this menu, and then it reads everything from the screen, even though now it's basically just bytes that are traveling through the wire to the robot instead of the screen. Previously, the screen interpreted these bytes as characters and then showed them on the LCD display. But now they are captured by our robot, and it reads what's going on in the screen, and then it sends that data by an MQTT to the cloud, and that's it. And you can schedule the robot to do this, for example, every 1 minute. We have now, that's kind of a common frequency, and to do things so that it's basically waits and idles for a minute, and then it goes and reads all those values and so on. But then on the cloud side, we have we then have like a data model and a database and so on, and we trained all the data points. You can access the data via REST API, or we can push it directly to a webhook or something like that. This is very kind of customer specific. But then you can
because we had a question about that actually that just says, asking about whether you expose the APIs that then other providers can tap into to use for whatever they need to. That's the case, right? That's how.
And basically, like it goes backwards as well, that you can actually send like a REST API call to our system, like to change a set point or change something like that, which is then translated into series of commands that are sent to the robot, which then goes like, okay, press 3 to get into programming menu and press 4 into that mode, and then do all those actions and then report back that it was successful.
Right, because I think that's an important distinction, isn't it? Because we're not just talking about getting the data out here. We're also we're not just reading the data. You're controlling the system as well, right? It's two-way.
That's exactly
Okay.
right. And actually, one of the very interesting things regarding the compatibility and the world, like I can see that there's a bit of an, let's say, a chasm between a modern cloud native prop tech companies and then the practical engineering and contracting folks and facility management folks, in the way that what kind of protocols or standards or things, what kind of data do they actually need. And we recently did the world's first upgrade of an Atmos Tech IC1000 to Niagara 4.9, I guess, supervisor by using our robot as the kind of a middleware. And during that project, we realized that, okay, REST is not really something, REST APIs or MQTT or stuff like that, is not really something that is scalable when it comes to the very practical everyday matters of real estate management using things like Niagara or stuff like that. So what we built is this kind of a virtual BACnet device that we actually take the data. So robot works as it does currently. We read the data and we put it into a cloud, but then we kind of reconstruct a virtual BACnet device out of that data, to which you can connect with VPN from your Niagara and get like all the discovery functions and everything that you need in a normal building management system. And then when you edit that BACnet object in the Niagara side, that command is actually, or the BACnet command is actually then translated back into a sequence of things that of tasks that go into the robot. So we are able to turn non-BACnet legacy things or legacy automation systems into BACnet compatible by virtualizing the BACnet layer.
Okay, that's fascinating. Yeah. Some more questions. I've got some as well. So, but let's do the ones from the listeners. Also, one here asking, what use cases are you seeing getting most traction?
Currently, the biggest or most attractive use case we have is smart district heating. So especially when you have a stakeholder in this kind of a smart city value chain that is not the owner of the building, but is actually really in a need of data.
Okay, yeah, because they're not incentivized to to actually renovate the system. Yeah. Okay.
They basically, like, district heating is the most common heating method in Finnish cities, and the basic principle is that you have a power plant and it heats water and it flows into buildings, and you have a heat exchanger. And you transfer the heat energy into your radiators and stuff like that. And you need to be able to, especially now because they're shutting coal power plants and everything, and you need to be able to do things using natural or carbon neutral means. You need to be able to do kind of flexible demand response on district heating. So and it's relatively somewhat simpler in residential buildings. Like our product is most useful in complex non-residential environments, schools, hospitals, and so on, where you have a much more complicated user profiles than in residential building blocks, where you usually have just a simple heating controller or something like that.
Yeah, because that's interesting you raise that, because that was another question we'd had. Can they operate, can these IoT gateways you have, they operate on buildings that don't have a building management system? So I guess the answer is yes, right? They can also be used with other types of control device.
Yeah, the management, like I try to use the term building automation system, even though I actually have a typo.
Yeah.
Building management. You basically, like, you have these three layers. You have the field level, like you have your sensors and actuators that are controlling the hardware. Then you have the controller level, which is some PLC or direct digital controller that is reading the data, doing basic logic, and then controlling things. And then you have the supervisory or the management level, from which you have some PC application or cloud application or stuff like that, that you are able to look at the whole system, how it works, and do adjustments and so on. So our system specifically targets the control level, and not the management level, especially for the reason that when you look at the way how, like, what is the life cycle of a building automation system, the field level is eternal, the control level is pretty much eternal, and then the management level is on some Windows XP PC mining Bitcoin in the cleaning closet. So you actually want to get rid of the PC part as quickly as possible, and that's one of the ways how you can do this kind of, how to say, almost like planned obsolescence, is that you tightly couple things together that age in different speeds. So you have a proprietary protocol that used to communicate between the controllers and the supervisory level. Okay, now you tie your supervisory level into some Windows 32-bit operating system that you know will be obsoleted eventually. So even if your controller would survive with its Linux stuff a lot longer, you kind of have to get rid of it. So that's the way that we try to kind of fight against that. We want to make it so that you can you get into the relatively stable part of the building automation, which is the controller, and not the local PC supervisory systems.
Okay. No, that's good insight. Yeah, no, thanks for clearing that up. Okay, yeah, and I can see the differentiation there, and it makes sense, of course, as you said. Like, it's the controller level that probably would benefit most from this opportunity. Other thing that I wrote down when you were giving your presentation was you mentioned brick schema. So I thought that was really interesting. I mean, so when you're taking the data and let's say normalizing it from some of these legacy control devices, then you are putting it into this open sort of standard data model. Is that's being done on the device? Is that correct?
No, it's not, because it's done in the cloud.
Okay.
So
but that's really interesting.
On the very minimal amount of logic is in the edge.
Okay. So you create the model in the cloud, but then again, for others who are using this to, as you sort of said, create a digital twin. I mean, that's perfect, isn't it? Like, they can then integrate that data with their existing data model, right?
I think, like, if you've been following the brick schema topics and so on, I think that one of the kind of primary problems that they are voicing, and that we also faced when we started in real estate data, was the fact that you have wildly different naming conventions in the building, in the points, actually, like
indeed,
what and it was very like we had one building. It has like a brand new structure where from Schneider had 2000 and something IO points, and they had this kind of naming convention guideline document, which said that you can freely deviate from this if you must. And it was deviated from in 52 different ways amongst 2000 IO points. But we actually been working on this for a long time, and I know that brick schema and the brick folks are doing work with the reconciliation API. We are taking a slightly different approach in which we try to build this kind of an probabilistic splitting algorithm that tries to find patterns from a large unspecified mess of point labels. And then we have these kind of rule sets that are applied that kind of encode these different guidelines into sets of rules. And then we are able to have this basically like, let's say that you happen to see a pressure difference sensor. Like there's a lot of things in brick schema that do not exist in building automation, because the building automation system, how it's programmed, doesn't know about the existence of a filter. For example, it only knows about the pressure difference across that filter. So, so you, because all the kind of inanimate chunks of metal like heat recovery systems and so on, they are not really semantically present in the programming of a building automation system, because it doesn't care about that. It cares about the temperatures and the pressure difference.
Right, yeah. It's just a dumb piece of steel metal or something. Yeah, okay. Yeah.
Values, but we are actually able to infer the existence of such things in the building based on the occurrence of certain types of points and the coexistence of this kind of a point and that kind of a point. And one of the kind of added insights that we get into the building automation, especially, well, not in all not in all instances of our robot, but in some way we actually can read the programming code on how are these things actually coded, and we can analyze this the source code of where you set up all the alarms or whatever. Like I don't know exactly how modern thing it is that the building automation systems are often programmed using these graphical programming languages, but at least the ones that we are been working on now, this Atmostech and so on, they are coded with structured text programming language, which basically doesn't have a concept of a function. It's just like just a sequential if else type of stuff. But we are able to kind of create a lot more insights about what's going on in the building automation and how it's built compared to your average kind of BACnet implementation. And I think one of the trends is also that which makes lives of building of those that are trying to integrate into legacy systems a bit complicated sometimes, is that protocols like standard protocols like BACnet are not always or quite rarely are sort of first-class citizens in the building automation, that you use proprietary protocols, you use proprietary data models, you represent the stuff inside your building automation system the way you feel best. And then because you have to comply with, like for example in Sweden, where they demand that it has to have BACnet compatibility or we won't buy it, then you kind of build that as an add-on on top of it. So you kind of create this component to which you need to transfer data from the actual process then to be sent out as a BACnet signal and so on. So a lot of information is lost on the way, which sometimes, not always, but sometimes we are able to get, and which is then useful in the digital twinning and making that scalable and mostly automatic.
Yeah, no, okay, that's fascinating. We've got a bit of time left, but I think if anyone wants to get questions in, now's the time to do it. Please do. We'd be happy to answer them. Someone here is just asking. Actually, that sounds like they may have to leave. But if they wanted to reach you or Valaa with additional questions, what's the best way of doing that, Ville?
I think LinkedIn, Ville Ilkkala. You can find me on LinkedIn. That's a good way. And then ville@valaa.com is
another way. Good. Yeah. Okay. Feel free to do that, of course, because I'm sure you'll be happy to answer any more questions about it. I mean, maybe we could just talk a little bit about the box itself, right? I mean, that's the. I mean, how are you selling this, right? Is it as a service, or are you selling it just as a piece of hardware?
No, yeah, it's a service. So it's a monthly. Basically, it's kind of all-inclusive device plus data plans plus APIs plus virtual BACnet devices plus everything as a single fee per month and no initial investments. And we try to do it in a way, or we try to build all our configurations in a way that we can actually send the device to the customer and they can go and plunk it down themselves, which makes it a lot easier for us and more scalable as well.
Yeah, easier installation, and then they can get the data out quicker, I guess, with less cost, right? Yeah. One of the questions I had was around. I noticed some of the names there are some of these older kind of controller devices, but I mean, how long does it? Let's say you come across, or you're working with a client, or they come to you and say, we've got this specific like building that we want to get the data out of. I mean, and you come across something you haven't seen before. How long does it take you to kind of understand that? Because I mean, I'm assuming some of these controllers may not even come with documentation.
Yeah, actually, they rarely do, and one of the things that happens quite a lot is that you don't obviously want to, as a building system manufacturer, don't want to have your end-of-life equipment's manuals lying around, so you purge them from the internet as well. So I actually do quite a bit of just calling. There was one automation system, legacy system, that I actually got a hang of the retired chief engineer of, and I had a great discussion with him, which I'm not exactly sure complies with all the how to say the NDAs or what have you. But yeah, it depends significantly on the way how complicated and what they actually are, what the customer initially wants us to do. We are able to do over-the-wire updates, and we are doing constantly, almost daily, firmware updates on the device.
Of course, yeah.
We can get into the habit of acquiring some data and do some learning as we go, and then we can enhance the features later, because sometimes you just want to get a subset of capabilities that could be done. So there's a lot of features or properties or values within these systems that you probably don't need to be able to change over API immediately.
Mm.
But it depends. It can take like one controller has taken us a couple weeks. Sometimes it can take up to 3, 4, 5 months if they are very complicated. But we actually try to evaluate these things in a kind of a market basis, that there has to be also a market for our solution.
Of course, yeah.
With the super fringe controller from some manufacturer that just came into existence in the late 80s, was able to sell 1,000 and then went bankrupt, it probably isn't worth our effort to integrate into that. But if you have like something like Honeywell Excel 5000 or something like that, that was the flagship of Honeywell's for 20 years. There's plenty of around, or Xentas from DAC and so on.
Yeah, yeah. And I suppose you've already been able to control those. Or
yeah, those.
Yeah.
And
you
also,
you kind of go on. Sorry.
Yeah, I was just saying that we try to, especially because we are kind of early on, it's like 19, 20 months that we've been first developing and then selling, and probably everyone who is working in the prop tech sector knows that it isn't the kind of fastest moving industry out there. We try to work with companies, either those who are offering services to buildings at scale, like facility management companies or real estate SaaS companies and so on, that actually have existing customer base, but they can only offer their services to a subset of the building stock of those customers because they have upgraded few, but then they have the kind of legacy long tail of random stuff that no one knows how to do anything about. So we could kind of help that kind of companies, and then operators and owners of larger buildings portfolios, where we could kind of be a strategic partner looking how to get this kind of a legacy first approach into a larger building stock, because that kind of gives both the time and resources for us to work on this. So if we work on the individual controller for the sake there being an individual building with one of those, it's kind of not so easy for us still, but hopefully in the future.
Because you kind of alluded to an interesting point about all of this, right? Like when mentioning about getting the data on some of these older devices, I guess, like, you know, it's quite a disruptive thing, this, right? Like there's some manufacturers who don't want the end of life of legacy systems to be extended. Yeah, so I think it's really interesting, but
yeah,
again, it's a challenge maybe that you've got to think about, right? In terms of how you take it to market.
Yeah, definitely. And I think like there's this saying that the automation system is the brains of a smart building, which I strongly disagree. I think like automation system is kind of like the brain stem or final chord of a building in a way that it kind of
the reptilian brain of
the reptilian brain of a smart building, because it has to be reliable. Like if you get this pressed, you don't want to stop breathing. so you want to have these kind of fundamental basic features of a building automation functioning, can be simple, and they are also very kind of complicated in terms or expensive in terms of upgrading the system. So you rather kind of put the smart stuff in the cloud, where you can freely integrate like hundreds of data sources and push stuff through neural networks and do predictive control procedures and stuff like that, and then push that back into the relatively simple building automation system. But this obviously creates the problem that you kind of have reached the pinnacle of process automation technology as it stands, what is supposed to happen in the building. Like I just checked that this PID controller, proportional integrate derivative controller, is going to turn 100 years next year, which is kind of like the workhorse of many of these processes. So that creates this kind of a pressure on how, for the system manufacturers, that how do you sell new hardware, and one of the primary ways of doing that is to make it harder to integrate them with cloud systems, because that's the way how you kind of at least can
upsell your latest version. Yeah.
But actually, like if I one of the customers said that he feels that every improvement that you do in building technology, or like in terms of optimizing things and so on, all the savings that you can generate from that is actually lost into the investments required to start using them. So
yeah, because
then it takes like 10 years, and then you have to upgrade the automation again, and so on.
Yeah, it's fascinating, and we've actually run out of time. It flew by, and I just want to say thank you. I think it's such an interesting concept, and I think it's very timely as well, as you said in your presentation. You know, only 96 weeks to 2030, and I mean, this is a way of being able to, you know, actually help extend the life of systems, defer maintenance plans. You know, if you're required to do that, to be able to, you know, just give people who own buildings and operate large portfolio an alternative, right?
Yeah, and thanks a lot for inviting.
You're very welcome, very welcome. And yeah, I guess if anyone has any questions, as Ville said before, you can find him on LinkedIn, send him a message that way, or visit their website, Valaa. It's valaa.com, right?
Yeah.
Yeah. Great. Okay. Well, just remains me to say, obviously, thank you to everyone who listened. Thank you to Ville. And we have recorded the session, so it will be available to listen again on YouTube. Please share it with your colleagues or anyone who you think is going to be interested, and subscribe to the channel as well. So yeah, and also wish everybody a happy Christmas, and see you in the new year. Thanks again. Bye-bye.
Bye. Thanks.